All right, let's go over variables and code structure. We're going to start out with a couple of quotes from some famous programmers. Our first quote is from E.W. Dijkstra, and he says, "Once a person has understood the way variables are used in programming, he has understood the quintessence of programming." He's expressing how important variables are in your program. They are the basis of all computers and all programming. It's how we store our information inside of the computer. If we weren't allowed to store any type of data or information in our computer, programming would not exist and computers would be useless. So it's very important to understand variables. What's great about variables also is variables are an expression of how we store things in a computer. And we can only store things in a computer a certain number of ways because a computer is binary. So once you understand the variables and how they're stored inside of your program in Java, you'll understand how variables are used in all programming languages. Here's another quote from Charles Babbage. He lived during the 17 and early 1800s. He's considered the father of the first computer. "On 2 occasions I have been asked by members of Parliament, 'Pray, Mr. Babbage, if you put into the machine wrong figures, will the right answers come out?' I am not able rightly to apprehend the kind of confusion of ideas that could provoke such a question." This leads to a famous programmer saying, "Garbage in, garbage out," meaning if our variables are not holding the data that we think they are, then our program is not going to give the right output. Remember that our program, every program, is built this way, and this is the basis of every computer. We have some type of input. We process that input. This is our program. And we use storage. These are our variables. And then we produce some type of output. Remember to keep this picture inside of your mind while we are writing and running our programs. All of our programs will be set up like this. Remember that our code structure in Java is that everything is inside of a class, and everything needs to go in between the 2 curly brackets in our main file or inside of a block of code. When the Java virtual machine starts running, it looks for the class that you gave it in the command line. Then it starts looking for a specifically written method that looks exactly like public static void main string args. Previously, I said this was our magical line of code, but remember this is the line of code that the compiler or the VM, virtual machine, looks for, and it runs all the code that are in between its curly brackets. You only can do a few things inside of any programming language. Because of the way a computer is built upon binary, we can only do these 3 things. We can do something. These are called our statements inside of a program, such as we can create a variable, we can print something to the screen, calling a method, or we can create a variable and assign it the value from a method. These are only 3 examples of things, but remember that a statement in your code is usually a line that ends with a semicolon. Now you can do something again and again with loops, or you can do something based on a certain Boolean condition called branches. Branches we're going to cover next week, and then loops we cover the following week. All programming languages do these 3 things, and all programs are written with these 3 things. So every program that you run is written with statements, branches, and loops. To create a variable is creating statements. So what do we need variables to hold? Our data. We need to hold the input to our program so that we can access that data later. This is what we call variables. There are two types of variables. There are primitive types and reference types. A primitive type is used for simple, non-decomposable values, such as an individual number or individual character. These are the types of variables we're going to create in our first level programs most of the time. We'll create integers when we want to store a variable that has no decimals. We'll create doubles when we want to create a variable that has decimals. And we'll use chars when we want to have a variable that stores a character. A reference type is composed of many primitive types that describe a single object. We don't get into object-oriented design inside of this class, but we do use some reference types, like our scanner keyboard. He's a reference type that's composed of primitive types. Alright, these are our different primitive types, and in the next slide here we have a very helpful table that shows all the types that we can have inside of our Java programs, all the type of variables that we can create inside of our Java programs. These are all the ways to store some data inside of a computer. Looking at this table, these are all our Java types, but if you look at other programming languages, they will have the same types of variables because it is the same computer and you can only store data a certain number of ways inside of a computer. So let's look at this chart. Now it's good to start to visualize our data and visualize what's going on inside of a computer. The better you get at programming and the more you program, the more you'll have to start visualizing what's going on inside of that black box. So when you think of variables, you can think of them as cups, or you can think of them as boxes. There's some type of storage location. I like to think of them as cups. So let's look at here. We have our byte, which is 1 byte. Remember that a byte is 8 bits of data. We have a short. He's an integer type, and he stores 2 bytes of data. We have an int, who's also an integer type, and he stores 4 bytes of data. A long is an integer type, and he stores 8 bytes of data. A float, floating point number and 4 bytes of data. A double, also a floating point with 8 bytes. A character, single character, with 2 bytes of data, and a boolean with 1 bit, or you can think of it as 1 byte of data. Notice that we have many cups that are of the same size. We have an integer who's 4 bytes, and we have a float who's 4 bytes. A long, that's 8 bytes, and a double, that's 8 bytes. And my question to you is, why are there duplicate cup sizes, or duplicate data storage sizes inside of our computer? And the answer is, an integer is 4 bytes, but it can only store a whole number and does not store any type of fractional or decimal part of a number. It can only store a whole number without a decimal part. Whereas a float of the same size can hold 4 bytes, but it can hold a number that has decimal places. Same thing with a long. A long is 8 bytes of data, but it can only store a whole number, whereas a double, same size, can store decimal places. This is because decimals are stored differently inside of a binary machine than a number without decimal places. And so you have to have 2 cups, or 2 different storage types, inside of your programs to store the 2 different types of data. Now a character is 2 bytes of data, but remember that your computer can only store numbers. So a character is stored as a number type and is translated by your operating system from a character to a number type and stored, and when it is read back, it is translated back from that number type to a letter type and then shown to the user or used in a file. All right, let's look at our size ranges over here. Notice that we have some size ranges. We can go from negative 128 to 127. That means if we tried to store the number 128 inside of a byte, it would fail. Same reasoning goes into our integer types. We can store a number from negative 2,147,483,648 to positive 2,147,483,647. Notice that all of the positive sides are one value less than the negative sides. And this has to do with the way that your computer stores data using 2's complement. Your computer can only store positive numbers, and it's its translation of that number that defines if it is negative or positive. Now, where did it get this arbitrary number? Did they just think of it out of thin air? And I would have to say no. They get this number from the largest possible value that can be stored inside of something that contains 4 bytes. If you look at this number in binary, you can see that if we use all of the digits, all of the 30 digits, excluding the first digit, which tells it if it's positive or negative, but all of the other 31 digits were ones, meaning the largest possible value that this binary number is holding, because remember 1 is bigger than 0 and we only have 2 digits. The largest possible binary value will give us this 2,147,483,647. And then the first digit, the 0, defines if it is positive, and if we put a 1 there, it's negative. Pay attention to this table. It's very important that we know the types of values that we can hold inside of our programs. We always want to use the correct type. You might think, well, I'll just use the double for everything. It's the largest number, and bigger is always better. So why don't I just make everything a double? Or why don't I make everything a long? This is always a bad way to kind of think about how to make numbers inside of a program. We actually always want to be efficient. Now, when computers were first invented, main memory, or RAM, was very important. You didn't have much main memory, and so you couldn't have a lot of variables, so you always had to be efficient and use the smallest variable that you could use to hold that type of data to save on memory. Nowadays, memory is pretty cheap, and we can add lots of memory to our computers, but we still need to be efficient as programmers. And if we're not going to store a decimal value, making everything a double would be very inefficient, because we're using 8 bytes when we only need to use 4 bytes. So, whenever you need to store a number without a decimal value, 9 times out of 10 we'll make it an int. And if we want to store a number that does have a decimal, 9 times out of 10 we'll use a double. But it's good to know all the variable types. And of course, we do use char to store our characters. These are all of our primitive types. Notice there are no string types in our primitive types table. It's because a string type is an object or a reference type, and a string is composed of characters. Here are some examples of some primitive types. Integer types can be 0 or -1. Notice there's no commas inside of our numbers. Here are some examples of some floating point types, types with a decimal value. Notice our character types have a single quote or apostrophe around them. And this last character is not a mistake. This is the white space character, and white space is its own character. And then, of course, Boolean types are the type true or the type false. And these are actually types. are values that we can put into a Boolean type. Variables store data such as numbers and letters. Think of them as places to store your data. They are implemented in the computer as main memory locations. The data stored by a variable is called its value, and the value is stored in the memory location. Its value can be changed. Naming your variables is important. Choosing names that are helpful, such as count or speed, is better than naming a variable the letter C or the letter S. If I had a program and I had a variable called number of baskets, note that this would make my program really easy to read because I would know exactly what this variable is holding. It's obviously holding the number of baskets. Note that we usually name variables like this. This is called camel case, where we put the whole word together without any white space, and we capitalize all the new words that are concatenated onto this name here. Notice that all of our variables should always be lowercase. That means starting with a lowercase letter. Uppercase letters are reserved for class names, and so we don't want to name our variables with an uppercase letter. It makes for better readability. A variable's type determines what kind of values it can hold. If I declared number of baskets an integer, I cannot store a decimal value inside of this variable. And very importantly, a variable must be declared before it is used. This is called your variable declaration. We're declaring to the computer that we need a main memory location of size int, and that we are going to name this location number of baskets. This is our declaration. Notice that we can declare two variables at once by separating them with a comma. We always end our declaration statements with a semicolon. So here are some more examples: declaring some integers, declaring a couple doubles, and declaring a character. I mentioned this before, but class types always begin with an uppercase letter, and remember to always name your variables with a lowercase letter. Here's some more rules about naming your variables. You can use digits, but remember that you cannot start a variable with a number. You can use the underscore character, but don't start a variable name with the underscore character. And the $ symbol has a special meaning, so don't use any special symbols. Just use letters and digits. You can't use dots or stars. And since Java is case sensitive, it will see the variable stuff with a lowercase s and the variable stuff with an uppercase s and the variable stuff all caps as three separate variables that are different. Of course, you can't use keywords as variable names. That would confuse the compiler. Let's talk about initializing a variable. This is putting a value into our cup, or a value into our variable. This is not called the equal sign. In math, we call it the equality sign. But in programming, we call it the assignment statement. The assignment statement takes whatever's on the right-hand side of the assignment statement and puts that value into whatever's on the left-hand side of the assignment statement. It assigns this value to this variable. Another way to say this is the variable named answer is assigned the value of 42. Here's some assignment examples. Notice I can tell amount must be a double. I'm assigning 3.99 to it. Note that on the right-hand side of my assignment statement, I can also have an equation. And I could use a variable on both sides of the assignment statement. When you first see something like this in programming, it might be confusing to see this on both sides of the assignment statement. But remember, this is not an equality sign. This is an assignment statement. The way that this works is, let's pretend that eggs per basket currently is initialized to 10, or has the value 10 in its memory location. It would then get that 10, subtract 2 from it, which would put 8 on the right-hand side of the assignment statement. It then places that 8 back into the variable eggs per basket. The number 10 is replaced by the number 8, and the number 10 is gone forever. Here's our question check. Which of the following can be used as variable names in Java? We've got some variable names here. Can a Java program have two different variables with the names myVariable and myVariable with a lowercase v and an uppercase v? And finally, give the declaration of a variable called count of type int and initialize it to 0. Where do we declare our variables? Customarily, we declare our variables at the top of our program. Note that we just have to declare our variables before we use them, but it's tradition and kind of a standard to declare our variables up at the top of our program. It makes for better readability. And our other programmers reading our code will know where our variables are declared. They can just go to the top of our program. Now we do things like this in programming so very much, where we have one variable on both sides of our assignment statement, that we can write it shorthand. This is traditionally the way that most programmers would write this line of code. These two lines of code do exactly the same thing. Remember what it does. It takes the value of amount, the current value, adds 5 to that value, and then places that new value, that's 5 more, back into the amount variable. It's so very common to do something like this that you can write it like this: amount plus equal 5. No space in between the plus and the equal sign. You can also do minus equal, star or multiplication equal, divide equal, and modulus equal. Most people will write it like this and not like this, but they do accomplish the same thing. Sometimes we need data from the user at runtime. And we've used this before, and we've created an object. This is actually a reference type variable. And it's a variable of type scanner. Notice the capital S, that tells us it's a class name. We can kind of think of this as a magical line of code for now, but we need to create this object in order to gather input from the user from our keyboard. We need a variable to talk to our operating system and gather that information or what they typed in at the keyboard. When we want to use this object, notice that this is the declaration and instantiation of a scanner object. When we want to use this scanner object, we put its name, then the dot operator, and then what value we're trying to get from the keyboard. Such as here, we're gathering an integer from our keyboard. It reads in one int value from the keyboard and assigns that value to our variable called eggs per basket, which better be an integer type. Here's an example from your text. Notice that we have our import statement. This allows us to use that scanner library. We create that object scanner. We named it keyboard. Remember that you can name this variable anything you want, just like we named all of our other variables. And it follows the same rules. We name it with a lowercase letter. When we want to use that variable, we then put its name, the dot operator, and what kind of value we're trying to gather from the keyboard, next int. Note if we were trying to get a double from the keyboard, there is a method called next double. There's another one called next long or next boolean. So whenever we want to gather information from our keyboard, we can use this scanner object and its host of methods. And in the example video, the video of the example problem, you'll see how Eclipse helps us with these method names. Note that we only have to declare the scanner one time, and we can use him throughout our program. Java is said to be strongly typed, meaning that we can't go from one type of variable to the other. But sometimes conversions between numbers are possible. This has to do with the size of our cups. This is why it's good to visualize our variables. Note that an integer is smaller than a double, so if I were to assign an integer value to a double variable, an integer whose 4 bytes can fit into an 8-byte variable, and everything is okay. But if I try to do the opposite, when I try to put a double variable, that's 8 bytes, inside of an integer variable, who is only 4 bytes, that's not going to work, and our compiler is going to yell at us. So remember, you can always go up in size, but you can never go down in size with your variables. Meaning you can assign an integer to a double, but you cannot assign a double to an integer. Sometimes we want to temporarily make a double value into an integer, but remember that this will drop all the decimal places and you won't be able to store any part of the decimal place inside of this integer. But it is possible to force the compiler to work and to make this into an integer and drop those decimal places. When you are typecasting, it is not changing the distance variable. It's not making this double into an integer forever. It's just for this one line of code, it's taking that double variable and dropping the decimal places so that you can put the integer part into this variable called points. So the value of int distance is 9, but the value of distance both before and after the cast is 9.0. Remember that when you do something like this, it does not round your decimal place, but rather just drops it off. Our key word for today was initializing, or setting a value to our variable. And if you have not initialized your variable, meaning there's nothing inside of your cup is empty, it doesn't make sense that you would be able to print that variable out or get any useful information from that variable. Such as if I wrote something like this and I declared my variable but did not assign it a value, this variable here is uninitialized. Now remember that Java is not a math language, meaning that sometimes your calculations will be wrong. Such as if I wrote something like this, you will not get the right answer in Java. Remember that if you want to do math, you should use a programming language like MATLAB. And this has to do with how binary numbers are translated, stored, and then translated back to decimal numbers inside of our computer. Little tiny bits of an error translating from a decimal to a binary add up and will give us the wrong answer sometimes. So remember that with variables you can use all of your arithmetic operations such as addition, subtraction, multiplication, and division. Here's an example. If hours worked is an int to which we assign the value 40, and pay rate's a double, which we have placed the value of 8.25, an integer times a double will give us back a double. So pay is a double, with the value of 8.25 times 40. Now remember that our division operator will work fine if we divide two floating point numbers. It'll give us the right answer and give us back an answer with a decimal place. But if I divide two integers, such as 99, which is an integer, notice no decimals, divided by 100, which is also an integer and no decimals, it'll actually give us the wrong answer of 0. And this happens because an integer divided by an integer gives us back an integer. And remember that an integer has no decimals. This is called int math and can lead to logic errors. So remember, make one of them a decimal, just put 0.0 after one of them, because a double divided by an integer will give you back a double, which would give us the right answer. So by putting 0.0 after each, and both or just one of these numbers would give us the correct answer. So if at least one of the operands is a floating point, then it'll give you back a floating point. Here's our modulus operator. If you've never programmed before, you might not recognize the modulus operator, but it's used a lot in programming. The modulus operator gives us back the remainder of the division of two numbers, and it gives us back that remainder as a whole number. Such as 14 modulus 4 gives us the number 2. So if I were to write this in my program, the answer would be 2. We can use the modulus operator in lots of cool programs, such as determining if an integer is odd or even, or determining if one integer is evenly divisible by another integer. Two more operators that we have are the plus and minus. It's because in programming we so very often want to add 1 to a variable or subtract 1 from a variable that we have this shorthand of the plus operator and the minus operator. Note how it works. Let's say I have a variable of type int. I've declared it here, and I've initialized my variable count to 7. If I write something like count plus, count would then equal 8. It's as if I added 1 to the value of that variable in RAM. And if I write something like count minus, it'll subtract 1, and so now the variable would be 7 again. Remember your order of operations or your precedence rules. And when in doubt, use parentheses. Remember PEMDAS, parentheses, exponent, multiplication, division, left to right, addition, subtraction, left to right, is our order of operations. So remember, if I want this addition to happen before the multiplication, I have to surround that with my parentheses. This can lead to logic errors if we forget our order of operations. Here's some example expressions of how we would write things in, let's say, mathematical expression to a Java expression, how we'd write it in our code. If we wanted to write something like rate squared plus delta, we'd write it like this in our code. Note in math, we can write a number on the outside of parentheses, and it's assumed that we're multiplying that number times whatever is inside of the parentheses. In Java, you have to explicitly put the multiplication symbol between that number and the parentheses. Order of operations also with fractions. The denominator needs to have parentheses around it. And of course, the numerator should also have parentheses around it. Here's our last question check. What is distance? and what is number. Remember that you should probably plug this code in if you're not sure about what the answers are, to make sure what you're thinking is the answer is the correct answer. Remember, we're doing a little bit of int math right here. All right, so that concludes our lecture on variables. Until next time.